Hello, welcome back to Educator.com and welcome back to Physical Chemistry. So today we're going to talk about the fundamental equations of thermodynamics. It is in this lesson that absolutely everything that we have talked about comes together. So this lesson is going to close the circle on thermodynamics. For me personally, no matter how often I present this particular the material in this particular lesson, I absolutely cannot get over just how unbelievably beautiful this stuff is. The circle on this closes in such an amazing way. Everything that we've worked on is now going to come together in just this absolutely beautiful way, at least for me personally. I hope that you feel like that also, even just a little bit. So anyway, let's just get started. Okay, so a system has two mechanical properties. Let's go ahead and stick with black. So a system has two mechanical properties. A system has two what we might call mechanical properties. They are the pressure and the volume. So P and V. A system has three fundamental properties. Okay, a system has three fundamental properties. And these fundamental properties correlate to the laws of thermodynamics, the zeroth law, the first law, and the second law. So they are, of course, the temperature, the energy, and the entropy. Zeroth law, first law, second law. These are the fundamental properties. Okay. Now, a system has three composite properties, or compound properties, if you will. They are the enthalpy, the Helmholtz energy, and the Gibbs energy. All right. Now we're going to derive the fundamental equations of thermodynamics. We're going to express the fundamental relations among all of these properties. This is what I mean by it all comes together. Okay. Now, as we mentioned before, we will restrict our discussion to systems that do only pressure-volume work. So we're not going to be concerned with other work, electrical, mechanical, or otherwise. In other words, our dW other is always going to be zero for us. Okay, so let's recall the general condition of equilibrium. So, general condition of equilibrium. We have minus du minus, well, I'll write out the whole thing, minus P delta V plus TdS minus dW other is going to equal 0. And again, this is going to be 0 for us. So we're going to have minus du minus PdV plus TdS is equal to 0. Let's rearrange this a little bit and express it in terms of energy. So we'll put the du on the left. It's going to be du is going to equal TdS minus PdV.